Let's do a quick overview on the oscilloscope. The oscilloscope is basically divided into 4 different sections. First, the display section, which is basically this part right here. The vertical section, which is this one for channel 1. This one for channel 2, as you have a dual trace oscilloscope. Then we have a horizontal section, or our time-based section, which is this part. And a triggering section of how we make the signal stand still on the screen. So let's take a little bit closer look first at the display section. So the display section for most part is talk about the screen of which the display is put on, and then usually there's an intensity control, which basically controls like a brightness of a television set, and our focus control, again, giving us the best picture quality that we can get. That pretty much is our display section. Our vertical section basically is our section, what we call our voltage. In other words, it gives us our amplitude of the wave. The setting has a signal per division, voltage per division section over here. So in other words, if it's set on 1 over here, each one of these boxes in the height is 1 volt. So depending on where we have this set will give us our display over here. We have what we call a variable knob. There's a calibrate portion of it in which we want to have that in the calibrate to get an accurate reading over here. It's made so that you can take a look at a closer part of a signal if you need to make it bigger. Again, you take it out of that calibrate mode and we no longer will have an accurate reading on the screen. This one here is basically just a position. If you look at our position, we will see that we move the display up and down on the screen. Basically, to get it centered or to make an accurate reading, we'll use that one. These buttons in here control which channel we're looking at. Here again, if I go to channel 2, now we would be looking at the channel 2 input instead of the channel 1 input. Again, channel 2's has the same functions as channel 1, and so we can look at either channel 1 in this case or channel 2. We can invert it if we need to. In other words, we would flip that signal if there's a reason we want to see the other part of the sine wave. We have a dual or a mono. In other words, mono means we're going to look at one channel. The dual means we're going to look at both traces at the same time. And again, a chop is a place where we can take this one and add it to this one. Or in another case, we could take it and subtract it if we invert it here. So it's just another thing that, another function that helps us. Also, I probably neglected to talk about is our AC, ground, and DC. Ground means we're going to ground this input. We shouldn't get a signal here at all. In other words, if we can't find our trace, in other words, for some reason our setting is like this and we're not sure where to find our trace, if we do this, we can easily get our trace back to center it, and then we can start from there to figure out where our problem is at. The DC portion of this means that we can test DC on this also. If for some reason we want to check the DC along with the AC sine wave, we can do so. So in other words, if there was a DC voltage on here, this would basically go up if it's a positive voltage or down if it's a negative voltage on the screen or on the end of the probe. So that's basically our vertical section. Our horizontal section, or our time-based section, is the part of the signal that deals with the squares horizontally. In other words, one of these squares is a division. If you look over here right now, it's set on 0.2 milliseconds. So in other words, each one of these squares is 0.2 milliseconds. So if we were trying to read a signal and get the frequency off of it, we would set this back, and probably like I have right here, we have, let's see, I'm going to use the horizontal centering so I can kind of take the signal and find one sine wave from here to here, and we could figure out what that distance is in time and then put 1 over it and get our frequency that we would have from our sine wave. So there's our explanation of like the time base. Again, we have a calibrate mode, so we can take it out of calibrate, we can adjust it, so if we want to look at a signal a little closer without worrying about what an accurate measurement, we can do so. Again, the positioning moves the wave so we can read it better. Our XY, be careful with that. Some people like to use that. Notice if I push that, the trace goes to a straight line. If this is the input for the vertical, so on an XY, so that means we will have our X-axis, so this would be our vertical voltage. A good way to check if you want to, rather than a sine wave and trying to read it, you can get a more accurate reading. But always remember to take that back out, because if you take this input off of here and you have the XY pushed, you end up with a dot and you will burn a hole or a spot in the screen on your display. So make sure that you watch that very carefully. And when you push the XY, also channel 2 will give you the horizontal voltage or the voltage in channel 2 horizontally is a better way to put it. And the last part of the oscilloscope we probably should talk about is the triggering. This is how we make the signal stable on our screen. We can use a couple of different ways of getting it there. This triggering is a way to make it stand still for us. In other words, we're triggering it a little closer, a little like plus or minus, sort of like, I don't know, the old VCRs used to have a plus and a minus to make the picture stand still. In other words, we're just synchronizing a little bit better. This one here will basically tell us what channel we're going to try to trigger off of. Right now we'd be triggering off of channel 2 instead of 1. Here we're alternating back and forth between the two. Here we'll use an external trigger, which the external trigger is right down here. We'd stick in a probe and trigger off of another signal or another place for that signal. So most of the time you'll trigger on the channel that you're using. Also we have, this one was made kind of for TV. So we have a TV horizontal, a TV vertical, and a line. A line means we're triggering off the 60 cycles that the scope is getting from the AC source. So that pretty much takes care of basic fundamentals of oscilloscope. Hopefully this will help you understand the different parts of oscilloscope. All oscilloscopes basically have all those same identifying, or those 4 divisions of an oscilloscope.